Right. Now, yesterday we have seen what is called as multi-classification. Multi-classification using confusion matrix, extended confusion matrix, or contingency table, and transformation of multi-class to binary classifier. Transformation of multi-classification to binary classification. We have also, in this regard, we have seen 1 versus rest. See, 1 versus rest, 1 versus 1. 1 versus rest and 1 versus 1. 1 versus rest means C1, C2, C3, C4, C5. 1 versus 1 means C1, C2, C3, C4, C5, C6, something else. Please. We have seen this yesterday. By using this, we have calculated code matrix or output matrix, also called as code matrix. Now we will see. Now for code matrix for the above is given as +1, -1, -1, +1, -1, -1, -1, +1. Now one classifier C1 from C2, first 3, C2 from C1, C3, C3 from C1, C2. If class labels are fixed at C1, C2, C3, then we need only 2 classifiers. This process is known as decoding. Now, suppose the word, now how do we find the minimum distance? Or how do we say this C1 is good, C2 is good, or C3 is good? How do we say that? Now, by using a word, let me tell you, a search word. By using a search word. For example, the search word is -1, +1, -1. For suppose, -1, +1, and -1. So clearly, if this is searched, so we will be ending up with class C2. So we say class C2 is selected or predicted. We can definitely say. What happens if my word is not found? If my word is not there? For example, if you take in this here -1, +1, or -1, -1. -1 and -1. So if you search here, this is the predicted one. This is the predicted. There is no problem for such cases. Suppose if this word is not there in the code matrix, then how do we assess, or how do we predict? How do we predict the? So this can be achieved by using what is called distance. Distance. What is called distance here? How do we calculate the distance? Suppose, I'll tell you the distance with an example. Generally, this distance di or di is calculated with, see, let us assume our word as W and this as C, WC, and a sigma. This is sigma Wi into Ci. So దీనికి ఏంటంటే ఒక by2 అను. So this is how it is calculated, some 1 minus. So ultimately, what is the result? What should be the result? So the result must be, listen carefully, if our word consisting of, say for example, -1, +1 and -1, then distance must become 0 with C2. You see here -1, +1 and -1. Because these two are equal, the answer is 0 for this. These two are equal, the answer is 0. These two are equal, the answer is 0. Suppose if they are not equal to 0, for example, you take +1 and -1. In this case, these two are not equal. The distance must become 1 at least. 1. The distance must become 1. For example, if one of the input is 0, if one of the input is 0, we have to say this as 0.5. In such a way, you have to select a formula, a model, a formula or a model. Now see here, -1 into +1 gives you -1. See, for example, if we apply this with equal ones, what happens equal ones? 1 into 1 becomes 1. 1 into 1 becomes 1. 1 minus 1 becomes 0. 0 by 2 is 0. See, clearly it is giving us 0 if W1 is equal to C1. If W1, WICI is equal, then it is giving clearly 0. 0. And if WI and CI varies, that is, one is -1, another is, for example, if the two are -1, -1 into -1 gives you +1. In that case also 1 minus 1, 0. 0 by 2 is 0. But if you take, no, one has -1, another has +1, then it is -1. Minus into minus gives you plus. 1 plus 1 gives you 2. 2 by 2 gives you 1. See, we can now clearly say that the distance, how distance is calculated? The distance is calculated by search word and a classifier word. ఈ క్లాసిఫైయర్ వర్డ్ ని సెర్చ్ వర్డ్ ని రెండింటిని కంపేర్ చేస్తూ we can easily calculate the distance. ఆ distance ఎలా అంటే, if the two bits are equal, the distance is said to be 0. If the two distances are not equal, the distance is said to be 1, -1. 1. And if one of the distance is 0, one of the bit is 0, the distance is said to be 0.5. You can calculate here 1 into 0, 0. 1 minus 0 is 0. 1 by 2, that is 0.5. See, very clear, 0.5. So this is how it goes. So this is how distance is calculated for each classifier. After that, no, whichever gives the minimum distance, that is said to be the trusted one or estimated one. Okay, so let us see an example for this. Now, let us see an example here. -1, +1, -1, and the scheme is an unordered 1 versus rest, then we know the decision should be C2. Elaga C. C2. -1, +1, -1. -1, +1, -1. -1, +1, -1. C2. So if matches, it is good. If matches. If not matched, how do you calculate the nearest distance? How to calculate the distance? Code matrix word 1 0 -1 1 1 0. For suppose if such word 0 0, let us take such word 0, then all will be 0.5. We have to apply what is called sigma WI CI, of course 1 minus by 2. 1 minus WICI by 2. 1 minus WI by CI by WICI by 2. For in this apply, we'll get 0.5. So this is called WD of WC is equal to sigma 1 minus WICI by 2. Sigma 1 minus WICI by 2. This is very important. Very easy. You need not go with calculation, multiplication calculation. No need. See, this is the very fundamental. If the two are equal, the distance is 0. If the two are not equal, the distance is 1. If one of the two is 0, then distance is 0.5. Simple, very simple. Let us now calculate a real problem with all these things. Now, see, a code matrix is given as this. A code matrix is given like this: +1, +1, +1, 0, 0, 0, -1, 0, 0, +1, +1, 0, something like this. Now calculate the distance. So, and finalize which one is the best one, for example. So the search word is +1, -1, +1, -1, +1, +1. See, if you search, this is not there in the 4 codes. This is not there. +1, first is not there. Second, third, fourth, not there. So we have to calculate the distance. Now the search word is +1, -1, +1, -1, +1, +1. Now the first code is +1, +1, +1, 0, 0, 0. Now, because these two are equal, the answer is 0. Because these two are not equal, the answer is 1. Because these two are equal, the answer is 0. This is 0. One of the input is 0. This is 0.5. Here, one of the input is 0, 0.5. And one of the input is 0, 0.5. The total, it gives you 2.5 for the first code word. So the distance D of S comma C1 is 2.5. Very important, my dear friends. See, even in the final examinations, you may be asked a question like, I'll just see, explain the following. Coverage counts as scores. Loss-based decoding. This is only called as loss-based decoding. Right. Now can we calculate for C2? We can write the distance as C2. This is 1 plus this is 0.5 plus 0.5 plus 1 plus 0 plus 0. See, because these two are not equal, we are taking this as 1. 0 is there, so 0.5. Again 0 is there, 0.5. These two are not equal, 1. These two are equal, 0. These two, it contains 0, so the distance is 0.5. The total is equal to 1 plus 1, 2, 1, 3, 3.5. So this is how distance is calculated. Very simple, very simple. Hope, no, right. For example, if you take C3 of this, if you take this, we have calculated the distance of this as 2.5. Calculated this as 3.5. What is the distance for this? And what is the distance for this? Now, if you see here, this is 0, -1, 0, -1, 0, +1. 0, -1, 0, -1, 0, +1. Right. Now, if you calculate these two, this contains, so this is 0.5 plus this is, as these two are equal, this is 0 and this is 0.5 plus these two are equal, so 0. These two, and it contains 1 0, so it is called 0.5, and this is 0 because these two are zeros. These two are zeros. Now, if you calculate, this is a plus. If you calculate 0.5, 0.5, 0.5. It is the answer is 1.5. And if you write here this 1.5. Now, if you calculate, we have to calculate now C4. Now, calculation of C4. Now, you can easily calculate C4 also. You can see here 1, 0. This is 0 కాబట్టి. Yeah, you have to write it as 0.5 plus again 0.5 plus what is this? These are not equal, so 1, and this is 0.5 and this is not equal, so 1, and this is also not equal, 1. So the total gives you 1 plus 1, 2, 3, 4, 4.5. So right, let us now so 4.5. So if you write here, this is 4.5. This is how it is, scores are calculated. So this is the predicted one. Our distance is less. It is having less distance. This is how the distance is calculated, my dear friends. Hope you understood. Let me just so if bits are equal, if the bits are equal, we'll take that as 1. If the bits are not equal, if the bits are equal, we'll take that as 0. If the bits are not equal, we'll take that as 1. If the bits contain a 0, it will be taken as 0.5. So this is how the distance between two words is easily calculated. Now this is called loss-based decoding. Loss-based decoding. This is only called as loss-based decoding. Vj is equal to final. This is the final one where k is given. K will be given k in k minus 1 into k plus 2 by L minus dj. dj is our calculation, our distance. Our distance. So our Vj is equal to vector Vj is equal to. So Vj is equal to. So our distance must be subtracted from this, where k is given. This type of thing is called loss-based decoding. Loss-based decoding. Sometimes you may be asked to just write loss-based decoding. In that case, you should write the example, and then if you write this formula, it will be fine. See this very good, right? Now, the definition of the distance between a vector of scores S and the jth code word Cj as, see, the distance between a vector S and the jth code word Cj as d of S comma j is equal to sigma I L of Si Cji. There is no new thing here, but no, and the minimum distance class is going to be predicted. This type of multi-class decision from binary scores is called loss-based decoding. It's called loss-based decoding. Loss-based decoding. So, right. Loss-based decoding under. Right. Next. Now, what do you mean by next one is this is multi-classification as binary classifiers. The next one is called multi-class scores and probabilities. Multi-class scores and probabilities. Several algorithms have been developed based on neural networks, decision trees, k nearest neighbors, knn, this is called knn, naive Bayes, support vector, SVM, extreme learning machines to address multi-class classification problems. These type of techniques can also be called as algorithm adoption techniques. Right? How do you assign? How do we assign? how do we assign scores? How do we assign scores? Scores, ఎలా scores assign చేస్తాము? A score can be assigned using what is called coverage counts. What is called coverage counts? A number of instances, the number of instances of each class that are classified as positive by the binary classifier is called as coverage counts. See, the number of instances are examples. The number of examples of each class that are classified as positive by binary classifier. See, we have divided the multi-class into n binary classifiers. See, we have divided the multi-class into n binary classifiers. Binary classifier means three. See, there are, if three classes are there, we have divided them into two class, different two classes. See, that is one versus rest, one versus one. So by using a multi-class classifier is converted into n binary classifiers. Now for each class, the number of instances of each class that are classified as positive, that is called coverage count. That is called coverage count by the coverage count. Let us see an example. Suppose we have three classes. Suppose we have three classes and three binary classifiers with which either predict positive or negative. There is no reject, of course. The first classifier classifies 8 examples as positive and no examples of the second class, and no examples of second class, and third as 2. Now for the second classifier, these counts are 2. So that is 2 means the number of positives. The number of positives for classifier. See, the first classifier classifies 8 examples of the first class as positive. The second classifier classifies the first class as 2 positives, 17, second classifier as 17, and third classifier as 1. Now, if third classifier classifies, the third classifier classifies A class with 4 positives, 2 B class with 2 positives, and C class with 8 positives. Now we can see, right? Now, so suppose a test instance is predicted as positive by the first and third classifiers. See, by the first and third classifiers, we show that first, second is 0, and third. By first and third classifiers, we see first and we can add the coverage counts of these two classifiers to obtain a score vector of 12 to 10. We are only learning the basics, terminology. We are just learning the terminology. So, right, if all the 3 classifiers fire for a particular test instance, అన్ని 3 classifiers fire అయితే ఒక test case కి అప్పుడు we write that as 1 1 1. So that prediction is given as 14 19 11. Now we represent. How do we represent this? We can describe this scheme conveniently using matrix notation. The matrix notation ఇక్కడ ఏంటమ్మా, ఏ క్లాసిఫైయర్ అయితే అవసరం అవుతుందో ఆ క్లాసిఫైయర్, ఏ క్లాసిఫైయర్ అయితే అవసరం అవుతుందో ఆ క్లాసిఫైయర్ ని 1 గాను, అవసరం లేని క్లాసిఫైయర్ ని 0 గాను, అవసరం ఉన్న క్లాసిఫైయర్ ని 1 గాను పెట్టి ఒక మ్యాట్రిక్స్ తయారు చేయటాన్ని దిస్ మ్యాట్రిక్స్ ఇస్ కాల్డ్ యాజ్ column matrix or column counts. And the second matrix is given as the number of examples, that is coverage counts. This is called coverage counts. This is called coverage counts. The left 2 by 3 matrix contains for each example a row indicating which classifies for the file for that example. The right hand side then gives the combined counts for each example. This is called multi-class scores and probabilities. This is how notation is. You have to understand the notation. The notation here is, my dear friends, coverage counts. Very important, coverage counts. This is only we can describe with an example only. You cannot have no exact definition for, already we have seen a rough definition here. Right, now, how good the scores are again. What is the performance? How do we measure the performance of performance index? Ella measure chestao. The performance index of a binary scoring classifier is the area under the ROC curve called as AUC, area under curve. So in the previous class, in the previous chapter, we learned area under curve. So this is the center one. Right? So if a classifier is like this, so the area under curve, so this is the AOC. This is called AUC, area under curve. ఏ దానికైతే ఎక్కువ ఉంటుందో that is called the best one. See, ఇప్పుడు దీనికి ఎక్కువ కదా, సో దీనికి ఇంకా ఎక్కువ ఉంటుంది కాబట్టి, so this is how area under curve. This structure is called ROC. This is model 1, model 2. This is AUC, area under curve, and which is again used here, my dear friends, which is used here. See, ikkada chala binary classifiers unnai ikkada. See, oka multi class classifier ki definite ga chala binary classifiers వచ్చేస్తాయి. వచ్చినప్పుడు మరి ఎలా ప్లాట్ చేస్తాము డయాగ్రామ్ అంటే, now we use the same mechanism but by calculating the average AUC over all binary classification tasks. అన్ని బైనరీ క్లాసిఫికేషన్ టాస్క్ ని కలిపి యావరేజ్ తీసుకొని ఆ యావరేజ్ ని తయారు చేస్తాము. Thereby we can easily assess the performance of this. So this is called multi-classification. Let us just have a small revision of what is called multi-class classification. Multi-class classification is by means of we can divide a multi-class classifier is divided into binary classifiers. Any binary classifiers ka divide chestam anede point. So here the two examples are there. See, 1 versus rest, 1 versus 1. So by using this 1 versus rest, 1 versus 1, we can easily predict, we can easily convert a multi-class classifier into n instances of binary classifiers. By using, now we can transform these n with into what is called code matrix or output matrix. Code matrix or output matrix. Now, if the code matrix is generated, how do we find the which one is exactly good, which one is good, which one is bad, or which one has to be predicted, In this case, for example, if -1 + 1 - 1 is given, that word is there in the code matrix or not, we'll search. If that is available, we say see to that particular class is good and that particular class is better అని చెప్తాం. ఒకవేళ దొరకకపోతే, if the word is not found, see, by using a formula like sigma I, where I from 1 to L, 1 minus WICI by 2, 1 minus WICI by 2. See, the ultimate goal of this formula is, See, our W is our search word, C is our code. So we have to say if these two are equal, it should give 0. If these two are not equal, it should give 1. If any one of is 0, it should give the middle one, 0.5. This is how a formula is designed, and this is how a formula is calculated, and you can easily see how it calculates the distance between the search word and matrix word. So this is how we can calculate. So this is also called as loss-based decoding. Loss-based decoding. This is called loss-based decoding and antaru. So the distance between a vector of scores S and the jth code word is called the loss-based decoding. Loss-based decoding. Loss-based decoding. So this type of multi-class decision from binary scores is called loss-based decoding. Now, several algorithms. Now we see multi-class scores and probabilities. Multi-class scores and probabilities. See in this, a score has to be given for each one. A score, then a score. How do we assign a score? How do we assign a score? A score can be assigned using what is called coverage counts. Coverage counts. The number of instances or number of examples of each class that are classified as positive by the binary classifiers, by different binary classifiers, is taken as score. That is taken as score. So, okay, example, this is it. Hope you understood. Right. In the next class, we will be going with what is called regression. What is called regression.